This is just a quick demonstration of how to test bottle caps. At the moment we're using some spring water, and we're also using an FCO 730 leak detector and an FCO 210 to introduce a leak. So on the top of the bottle here I've used a piece of tube which I've dubically clipped to make a leak tight seal, and then I've put it onto a brass connector, and then at the top of the brass connectors there's some tube running to the leak detector. So effectively what I've made is a chamber over the top of the bottle top. You can also see here the water level in the bottle, and you can see that there's very little space between it and the top. The more space you have, the easier this test is. We have the bottle that we're testing here. We have the FCO 730 leak detector here. I have connected to the front panel a micro calibrator FCO 220. I can generate a leak with a needle valve here, which will replicate a leak in the bottle over there. So we're going to run a test. I'm going to press start. You'll see that it pre-fills to 330 millibar, and then it dumps that pressure into the chamber, and we're testing now at around 100 millibar. There's no leak in this, so I get a green light and practically 0 cc's per minute. Now what I will do is I'm going to open up a leak path, and I've already generated with a needle valve a leak of around half a cc per minute. We'll press start. Runs through the same cycle. You can see here around half a cc per minute. You register a fail just here of around half a cc per minute. I can now do one at 300 millibar. So we'll run a test at 300 millibar, press start. You can see that I haven't induced a leak, so this is a non-leaking part, and I get practically 0 cc's per minute. Now I'm going to open the valve to let the leak into the leak circuit. So now I've set the needle valve to a half a cc leak, press start. Part fails at around half a cc. So with the valve closed, I've set it to the 500 millibar test. There's no leak in the circuit. Press start. We have a leak rate of around 0.1, 0.2 of a cc per minute. So as before, I'm going to open this valve. I've adjusted it now so that the leak is half a cc at 500 millibar. We press start. And it fails at around 0.7 of a cc per minute. So this test has been set up to run as close to 0 as possible, but I can speed this test up by taking out a lot of the free air that's in the chamber, of which there's quite a bit. Right, just going to take the chamber bit off. And you can see there that there's an awful lot of free space, and this free space increases the cycle time and decreases the sensitivity. So you can see that there's an awful lot of improvement that I could make upon this. The next thing that I need to do as well, you can see that this bottle top is fine, it's leak tight, it's got no hole in it. We want to test one that does have a hole in it, and this one, I don't know whether you can see, but I put a hole in the top of the cap. So swap these over. I'll put the chamber back on top. So when the cap's got a large hole in it, we press start, fills, but it doesn't see the right pressure when it transfers it over, so you get 2 red lights and a fail.